session on the JVM, right, internals. Now, because we're doing it first time, so we'll not really go to very advanced levels, how to really fine tune your GCs and all. We'll definitely have a session for that because we want to set the context this for the basics of the JVM, right. Once you guys are up to the mark with what we are doing, and we'll definitely, I'll give you a few pointers how to really exercise these things in one of your components, and I'll tell you a few things which I expect you guys to go back and do, right. Once you do that, maybe on the next visit or sometime, we can do another session which gets into the finer details, right? How to finally fine-tune your GC, how to really extract the maximum performance out of it, right? लेकिन आज हम क्या करेंगे जो कि basic is needed for you guys to operate. So a few examples, right? You should be able to see कि मेरा जो JVM है, how it is operating, right? Memory-wise, what is happening here, right? कौन सा GC algorithm use कर रहे हैं? Why you are using that, right? GC pauses कितनी हो रही हैं? GCs frequent हो रहे हैं नहीं हो रहे हैं? Why my application is consuming more memory, right? If my CPU is high, how can I debug that, right? Is it really my application should take that much CPU or not, right? So let's scrape these things which are important for 90 to 95% of your day-to-day activities, right? The rest 5% of the things which we do is basically now I want to optimize my application for another kind of performance notch and all, or I might want to debug live, take some traces, right? Or uska memory, CPU, uska samples leke. So that we will take in the next session, right? Because otherwise वो बहुत ज़्यादा वो हो जाएगा. So guys, we'll start with looking at what JVM means, right? So everyone here is Java developers, right?
Yes.
So every one of you know that you write the Java code, and they made it such that you can write the code once, you can compile it, and you can run it wherever you want to, right? That's where the JVM comes into picture. It bridges the gap between the target machine or operating system you are running your code at, and the way you have compiled your code into in the bytecode, right? So whenever you have a code, this code is run inside the JVM and not directly on your operating system. That's what the JVM comes into. And the major components of the JVMs are you have a hotspot VM runtime. This is the guy where your threads get created, thread management happens, right? Class loading happens, all those basic. जितने आप thread pass करते हो, arguments pass करते हो, you might have passing XMX, you might have seen a lot of arguments you guys pass to your JVM. This is the guy who bootstrapped the whole thing, right? Now, another major component is the garbage collector. We'll spend a little more time today here. This is a very important component because this is the guy who takes care of your memory aspects of it, right? As you all know that Java does use garbage collection, which means you don't have to free the memory, right? I mean, few of us who have coded into C++ and all, and C, we know that you have to take care of freeing your memory yourself, right? So Java takes that headache from you, but then which also means that we need to have more understanding what it is doing, right? And third section is the JIT compiler. So Java has a very advanced JIT compilers and all, which takes care of optimizing your code, right? So it doesn't really mean that every time your bytecode goes and then Java every time translate into your machine code and start executing. You have a JIT compiler which understand if your frequent code is running, hotspots and all, it automatically converts that into your machine code and keep that cached. So the next time it doesn't even have. So this I'm telling you because sometimes we get into a little bit of kind of premature optimizations, right? I've seen few people get into abstract class versus interfaces and all, right? So it doesn't really matter in modern JVM systems, right? You should more focus on writing a concise and clear code and as much as readable and all, right? Because there are certain performance aspects which JVM automatically takes care for you, right? So unless otherwise you see that really there is a need for a performance optimization and you prove that by data, and we'll look at how we'll prove that. You shouldn't really worry too much about people say that इसको यहाँ ऐसे मत करो, इसको interface define करोगे तो it will be less efficient than abstract classes and all. So those things doesn't really work in modern JVMs and all. Right? So this JIT compiler is also important aspect. So these are the main components, and what we will do is today we will more and more look into the aspects of the garbage collections. Right? This is one of the interesting part also, how it really works. And another angle is that the servers which we are running today, right, in Compass also or wherever we are running here, right, after this exercise at least you guys can go back and figure it out that are they right sized or not, right? Can we further optimize them? Can we really downsize them, right? Or even increase or decrease, or across family also should I really move, right? So say हमें वो भी idea लग जाएगा, and maybe because of that we'll be able to optimize the cost also, right? Because you all know that as of now our current focus is to optimize the cost within Revio, right? Everywhere, everyone is doing their own bits to reduce the cost, so maybe this is an opportunity for us to do that, and you guys will learn a lot about the JVMs also, right? So abhi tak any question, guys?
So hotspot VM is the one which actually talks to OS.
Yes. So this is the VM which creates a thread. It creates native threads. तो यहाँ आपका C++ का पूरा कोड रहेगा बीच में या C का जो भी होगा. And that is where it will interface towards your operating system.
Platform agnostic होता है.
It's so JVM जो आता है, so you have a different JVM runtime per operating system.
अच्छा.
Per operating system, per architecture.
Per
architecture अच्छा. But the performance is similar for let's say अगर
performance is similar.
Windows पे चल रहा है या Linux पे चल रहा है.
हाँ तो exactly. उसका कोई इसको ज़्यादा फर्क नहीं पड़ेगा. So if you have a different CPU, मतलब उसके 4 CPU nodes and memory wise and also I don't think you'll see much difference.
But underlying architectures बहुत different होते हैं OS के.
हाँ तो अगर your application is written very specifically, right, which is very, तो कई बार क्या होता है कि what I've seen in the past and I'm talking about 8 to 10 years back, right, when Java was written, the जो उसका, if you don't have multiple threads, if you have very less threads and all, it used to run very fast on Spark kind of systems, right? Sun Spark I'm talking about, right? Architecturally, it used to support those kind of systems. But when your x86 came and the servers become cheaper and they start giving you more CPUs and all, those kind of applications start running much faster on the x86 kind of applications, right? तो वो होता है skewedness आती है because your basic architecture is different, right? But if you look at the Linux kind of systems, right, there उसमें कोई ज़्यादा आपको फर्क नहीं पड़ेगा कि whether you are running Ubuntu or whatever it is and all, so because your underlying architecture is pretty much similar. हो सकता है Windows और इसमें आपको benchmark करना पड़े, right? Because Windows will use a different architecture underlying and all, right? उसका threading model अलग होगा, उसका IO model अलग होगा. Because your how you handle your I/O and all really depend, right? And I/O use होता है Linux में, but I think Windows has better multiplexing and all with I/O and all, right? So maybe your I/O characteristics might change there, right? लेकिन basic जो general purpose applications हैं, there at least from the coder's perspective ज़्यादा फर्क नहीं पड़ता है, but fine tuning करनी आपको करनी पड़ सकती है उसमें.
And probably for applications for which Java is actually used, वहाँ पे जैसे paging, caching इस type की चीज़ों का इतना ज़्यादा वो नहीं करते होंगे.
हाँ मतलब इतना कोई फर्क पड़ता नहीं है उसका, right? So if you typically write applications where you depend your operating system to cache stuff for you, right? I mean your typical MySQL or MongoDB and all, right? Where they don't really cache separately something. It's not like your MySQL starts with X amount of memory, right? Of course it caches few of your indexes and all, but then it mostly depend on your page being cached into the memory, right? वो Java का architecture वैसा नहीं है. So Java doesn't really depend too much on that. Because we'll see that when you start a Java, you start it with a fixed amount of memory, right? You tell it that, hey, I mean, give JVM 4 GB of memory out of 8 GB. And then it manages this heap within that 4 GB itself. Now there are downsides if your application doesn't need 4 GB, your Java will still take 4 GB. Because it doesn't care, right? Because वो Java ने allocate कर लिया है. अब उस 4 GB में, are you really putting objects on? That's where we'll look at it, right? Well, that's where we look at it, how to really figure it out. Have we really given those options correctly or not, right? Are they the optimal things or not, right? So guys, so see, GC, garbage collections, there are a lot of algorithms, right, out there for doing GCs, right? You have something called reference count. होता होगा कई languages में use होता होगा where you just keep a count of your objects which are, so you have an object, you keep a count on it, how many references it has, and as soon as it becomes 0, you kind of dereference that, right? There are a lot of problems there. If you have a circular, it becomes very difficult, one object find another, right? So, but coming fast forward, and what Java uses something called generational garbage collection, right? Now, what is a generational garbage collection? What does it mean is that your heap itself is divided into multiple generations, right? We call them young generation, old generation, and permanent generation. Now it depends on how somebody has implemented. In current generation of Java, you have these. In fact, this is a little different. We'll talk about this. But if you say you have 2 generations, young generation and old generation, right? It might be there that .NET might use 3 generations, or somebody else might use 4 generations, right? Now there's something called weak generational hypothesis, right? And the whole idea is based on that, which means that one is that either your objects will die young, right? And if they don't die, they will remain for a long time. So that is your weak generational hypothesis, right? तो या तो आपके objects जो होंगे you will create them and they will get garbage collected very soon, right? Or if they are not getting collected very soon, it means they're gonna live long. So let's take example where you guys can connect. So when you write your applications and you guys might be using Spring Boot or whatever it is, right? You write certain services, right? Now those services are something which will never get garbage collected, right? Because services life cycle is tied with your application life cycle, isn't it? So those are the kind of objects which will always stay, right? But there are certain objects which gets created when you execute something. Just say somebody gets a call to your controller, you create an object, you call a method on it, do some calculation and exit out of that, right? But those objects gets garbage collected very soon, right? So those are the guys we are talking about, right? Infant mortality rate has to be pretty high in a typical Java system, right? For your GCs to because this whole theory of generational garbage collected is depending on the weak generational hypothesis, right? So I'm going to check some notes like the references place that I can tell you some few important things. तो इसमें ये है कि so one advantage is that, and I will come back to that, these, because the characteristics of objects are very different for every generation, right? We know that these are the objects which will stay young, right? These are the objects. तो हो क्या सकता है कि we can apply different algorithms here. We don't have to stick with one algorithm to one region, right? Depending on our need and characteristics, we can use different algorithms, and this is what exactly Java does. Java uses different GC algorithm for collection of these objects and different for these. Right?
So, I mean, objects are ordered on the basis of creation or on the basis of last usage according to the category?
So, we'll come back to that. We'll come to the life cycle of object, how it happened, right? Achha. So, to answer your question, what happens is, whenever a new object is created, right, it always created in hidden space, right? That's called its hidden, right? I think it came from that hidden and if or something, yeah, like that, right? So that's where it comes to. Now this young generation is divided into three parts, right? Hidden, survivor 0, survivor 1. Right? So hota kya hai? A new object came, it got allocated into hidden space. Over a period of time, what will happen? Your hidden space will get filled, right? The moment your hidden space get filled, a minor GC kicks off. This is called minor GC, right? If you look at your logs and if you get confused what this minor GC means, right? That is what we are talking about. Your hidden space is filled. That is why he's not able to allocate, and you'll see that allocation failure, right? When you see the reason for GC, right? Java tells you that why it kicked off the GC also. It will tell you the allocation failure, which means he was not able to allocate object to here, he kicked off a GC. What he does in that GC is that he'll figure it out. What are the live objects? And guys, this is a pause. Your application is paused for that time, right? Your application cannot execute during that time, right? Just keep that in mind because that will impact what kind of algorithms you choose.
There will be global lock.
Globally, nothing can move now at that time around. It's frozen. Your application is frozen till this time is happening. So he'll figure it out that what are the live objects. Now, how can you figure out the live objects, right? The typical thing is that you look at your thread stacks because those are your roots, right? Look at from the thread stacks, what are the objects which are going where, right? And figure it out, right? What are the live objects, right? Now there's a cache there, and we'll come back to that. There are very good algorithms which are being used, right? Car table wala use hota hai. We'll come back that why that is used, right? So in a nutshell, what will happen is the live objects here. What are the live objects? They'll be moved to S0. Then it will clean up the whole space from hidden. Hidden पूरा फिर से खाली हो जाएगा. Objects जो आपके बचे होते हैं S0 में चलेंगे, right? Now again it will start doing that thing. When it will again filled up, right? What it will do is that the survivor 0 वाला जो आपका space है, right? So यहाँ से he'll move the object to S1 and S0 object he'll move to S1. So he'll keep swapping them, right? And for every object it will tell that what is its tenure, right? So it will keep increasing. How many garbage collection it has survived, right? So उसका survival क्या है? And when an object का survival reaches a threshold, that object is moved to the tenured, old generation.
How it decide that survival period?
So this is GC where you can also put in a flag, you can also decide what you want to put a limit, and there are some same default limits which GC has, right? So let's say I have an object here and I've run 4 times the GC and he has survived all four GCs. Now Java has decided this object is has to be promoted to the tenured space.
So all the life cycles are not on the basis of time, but on the number of GC iterations.
Yes, GC iterations, right? So there's no timers running, right? So GC is lazy and it tries to be as lazy as it can be, right? तो वो जब GC चलता है तब वो decision लेता है, right? कि यार मैंने 3 बार GC चला दिया, लेकिन ये ऑब्जेक्ट तो अभी भी यहीं पड़ा हुआ है, right? So then he figured out कि let me just move it to the old generation space, tenured में move कर देगा. Now होगा कि over a period of time when you guys are doing this iteration and you can figure it out कि आपको old generation भी भर जाएगा, right? That is the time it runs the full GC, right? Now that is a very different from young GC. Full GC के time पे it cleans up everything, right? He looks at the old space, old generation, then he again figured out कि what are the live objects and all, and then he cleans up the space there, right? Now permanent generation is a little bit misnomer. It shouldn't be a part of generation first of all, because generations are where you're moving the objects, right, from one generation to another. This is a space where your class loading, class metadata, information about the JVM, right, your string internalized. Now that keeps changing from JVM to JVM. I don't know in latest JVM do they keep the string intern into this space or they have moved to the heap. But this is a space where GC almost doesn't give you much benefit, right? यहाँ से कुछ GC collections होती नहीं ज़्यादा, because they are very fixed object. Your classes are loaded, there's metadata and all. This is something for JVM's internal keeping, nothing to do with our application. Of course, you have to allocate enough space so that your class loading and all can happen, right? But apart from that, there's no problem if you see this space is 90%. There's nothing to panic there, right?
So application code also reside here.
हाँ, तो आपके कोड ब्लॉक्स और आपके क्लासेस जो आपकी क्लास कंपाइल्ड हुई हैं वो सब चीज़ें जो भी आपके JVM को whatever reference check and whatever he has to do for internal metadata and all, those all data is decided here, right? So this is how it really works. Now I was giving you an example. Now see, one thing comes to your mind that now if you had to figure it out, what are the live objects here, right? Now he has to scan because there might be certain object here who might have a reference here. Now if he has to scan that, then he will anyway be scanning whole generation, which means that at every minor GC he might have to do the major GC, right? So there's no benefit of that, right? So that's where your good algorithms comes. There's something called car table data structure, right? For fast minor collections, में होता क्या है कि it maintains a card, right? So what it does it divides your old GC into chunks of 5 and 2 bytes. 512 बाइट का एक रीजन बना देगा वो, right? And he'll have your क्या होता है उसको array where every one of that will have a fixed location in your bitmap kind of thing, right? And what will happen is that every time you allocate an object and it has a reference to that region, वो उस region को he marks that one bit जो उसके लेगा, it will mark as a dirty. So what happens is when he does a GC, he only looks to those regions, right? He doesn't look entire old generation. Otherwise, there's no point, right? Your minor GC will convert into a major GC, right? So that is how it makes sure that your minor GCs happen very, very fast, right?
So when is this marking happening? When we create an
Every
object?
time your objects are created, references are updated. So there's something called write barrier which JVM has implemented, right? So that time it really keeps doing that, right? Allocation. Now one good thing you guys can see is that the allocation is very fast because hidden space is empty, right? Now there is something called bump the pointer, right? This is how I don't know if you guys have worked in the old times when you used to work in the C systems and all, right? And sometimes we had to make application very fast and all. What we used to do was we used to allocate a big array in the initial itself in the C, and then we used to get objects allocated ourselves there because contiguous memory allocation is always faster, right?
To reduce cache misses.
Exactly, right? So उसमें ये यही करता है. What he does it because your hidden is empty, it start allocating from one side and keeps bumping the pointer and keeps allocating the next object. It's very fast. Allocation is very fast there, right? Now the slowness can come because you will have multiple threads. Java has multiple threads. We all have so many CPUs now, right? Nobody is working on a single CPU. So now the question will come that this fast, the bump the pointer cannot work in the multi-threaded environment. So they again have something called a thread local allocation buffer, TLAB करके बोलते हैं इसको. So होता क्या है कि when you run a Java system, right? Every thread is allocated a small region for themselves. So the bump the pointer is local per thread for that, right? So that's how it really works, and that's how it optimizes your fast allocation, right?
Per thread.
Path, right? So it has a small region allocated per thread, right? Now there are some edge cases where your TLAB fails to allocate objects, right? And we can figure out that from the JVM statistics. That's where your objects can start allocating into old generation directly, right? We'll see that, right? I mean, but those are very doesn't happen in 99% of the cases.
But
right?
threads has a life cycle can be lower than application, right?
So that is fine. So allocation deallocation चलता रहेगा. अगर you have a thread, It'll have its own TLAB. You'll have allocated here. That thread is gone. That will again be reclaimed.
So when we are going to create, it will create a space here.
When the next GC occurs, just seed and fill हो जाएगा, वो deactivate threads का TLAB हटा देगा.
अच्छा.
हाँ तो वो सब memory management आपका इसमें होता है. So this is a very basics how your garbage collection works, and we will see a live example of it also happening in one of the applications, right? I'll try to log into some of the boxes which might have or we all सब server पे Java ही चल रहा है सर. And we'll see.
सतीश, इनका जो actual capacity है या space है, वो constant रहता है, वो dynamically change होता रहता है based on what sort of feature application has.
So there are few algorithms, or most of the algorithms have this fixed, right? But you can change it, right? Now ratio रहता है. So you have, and you can even define within the young generation what ratio you want for hidden and survival and all. You can fine tune them, right? But the same defaults are decent for running most of the applications, right? Unless otherwise you are very sure that you want to fine tune, and that's where I'm saying maybe we should dedicate one more session for that, right? There's no need to ज़्यादा ज़रूरत होती नहीं इनको handle करने की, right? But there's a new GC algorithm which is called G1, right? which is now default with the Java newer system, right? Garbage one, right? Or garbage first करके होती है. G1 is a garbage first, right? We'll see that, and that has a very different approach of doing GC, and which might even change the way GC is being done in future, right? It might just make it very live, right? मतलब pauses शायद होंगे नहीं, right? It is. So we'll see few algorithms. Concurrent mark and sweep रहता है. We'll see which application need what kind of algorithm first, right? We'll see from there. Then I'll move to G1. And I'll say why G1 has changed the way GCs are done, and now going forward maybe how it will become a default. You may not even have to choose. Just run with G1 and you're done with it, right? I mean, it doesn't really matter what kind of characteristics you need, right? So this is clear. What are these different spaces and how objects move and when GC kicks up and when major GC happens, right? This is what you can see from here, right? And sometimes what happens if these spaces also get filled, right? S0, and you don't have a space to move S0 to S1 and whatever it is also, that time also major GC can kick off, right? So there are a few corner cases, right? But when you see your GC logs, it will clearly tell you that why GC has kicked off, right?
एक सतीश basic question, तो इसमें demotion type नहीं होता basically S1 से S0 चला गया?
नहीं. तो these spaces are just for swapping, so that it can happen faster. In regions का ना कोई semantically कोई meaning नहीं है. They are just two regions, but I don't want to deallocate object. मैं fragmentation यहाँ करके I don't want to do that. So I just move these spaces pointers here to there, right? That is why they are kept. But otherwise semantically there is no demotion between S0 and S1. मतलब वो हर cycle में S0 S1 बन जाता है, S1 S0 बन जाता है. They just kept it to copy one from here so that the other is empty. That's it. And we can keep the count of that is objects जो है उसका how much GC this guy has survived, right? उसके अलावा इनका
मतलब ऐसा नहीं है कि sorted order of GC survival के basis पे मैं उनका kind of allocation करूँ कि ये यहाँ बैठेगा यहाँ.
नहीं ऐसा कुछ नहीं है. So these are very dynamic. I mean,
तो इसके अंदर मतलब minor और major GC parallel में चल सकता है.
जब तुम्हारा full GC चलता है तो वो parallel में ही चलता है.
अच्छा.
But see, there is a तो minor और major शायद parallel में ना भी चले. So there are few algorithms which runs your GC itself parallelly, which means that it use multiple threads to do your GC, right? वो thread उस time पे क्या कर रहा होगा it's a different thing, but it try to do your GC in parallel, right? Allocating multiple threads to that.
जैसे hidden memory भर गई और हमने minor GC चला के उसे खाली कर लिया और लेटर से S0 S1 भी भर गया और hidden अभी भी खाली है तब तक global GC hit नहीं होगा, right?
जब तक वो hidden पे इसको allocation मिल रहा है.
जब hidden और S0 S1 सब भर जाएगा तब
उसको करेगा. लेकिन जब वो करेगा full GC तो full GC में हमेशा minor GC होता ही होता है. So definition of full GC is this plus that, right? मतलब ऐसा नहीं होता कि तुम्हारा full GC हुआ तो और minor नहीं हुआ तो minor को reclaim वो सबको reclaim करता है उस time पे.
And if I might add, like for certain algorithms like mark and sweep and all those things, it's assumed कि like वो पूरा ही GC कर ही रहा है in the sense कि like minor GC और मेजर जीसी ओवरलैप कर नहीं सकता क्योंकि उसको पूरा डोमिनेशन ग्राफ चाहिए ही होता है ना, मतलब उसीलिए वो उसी टाइम माइनर वाला जीसी एज अ पार्ट उसका हो ही जाता है, वो डोमिनेशन ग्राफ एग्जामिन ही कर रहा होगा ना।
फुल जीसी में देखो वैसे भी क्या है कि व्हेन इट इज डूइंग फुल जीसी राइट, इट हैज टू फिगर इट आउट
ऑलरेडी मेस्ड अप,
राइट,
तो
बिकॉज़ इट डजंट नो दैट देयर आर रेफरेंसेस फ्रॉम हियर टू हियर, हियर टू हियर, राइट, सो देयर इज नो कार टेबल एंड ऑल विल नॉट गेट यूज्ड दैट मच दैट टाइम, राइट, तो उसको उस टाइम वो करना ही पड़ेगा, सो देयर इज नो ऑप्शन फॉर हिम, he has to completely clean up the entire space and all, right. अब इसमें क्या है कि what we will actually look at it is so as I was telling you guys, right, there are different algorithms, right, and earlier it was used to be debate कि ये use करें वो use करें, and of course within Revigo also I see that we are using CMS as well as parallel GC, right, parallel old GC or whatever, right. I've seen many applications using parallel old GC, which is default till Java 8, and I've seen I don't know the Compass side, but at least I've seen in the Zoom side we have started using G1 collector also, right. CMS I've seen in the Freight side also, CMS being used, right. Now let's look at what do they all mean, right. Serial GC, it's a very simple, right. What is it does is sliding compacting mark and sweep. तो आपका पहले you have a space, it will mark what are the live objects, तो live object हैं, it will move them to the starting position, उसके बाद जो पूरा space बच गया वो खाली हो गया है and that becomes a garbage, right. It does it serial है तो serial ही करता है, एक ही thread में करता है, it doesn't use multiple thread for it, and of course it's a single thread और इसको mark करना है, then it's a stop the world event, right, which means your application will not be working at that point of time, right. That's a serial GC, right. Basic but pretty decent because one is that it doesn't defragment your memory, because it doesn't defragment your memory, which means memory allocation becomes easier and should be faster, right.
It's kind of like also adding defragmentation as a part of it.
It is not doing defragmentation.
I mean, it is collecting.
It's compacting them, yes. So that stops defragmentation.
Defragmentation होगा ही नहीं तो फिर
that stops fragmentation.
Sorry, that stops
fragmentation
fragmentation.
नहीं होगा तो defrag की जरूरत नहीं पड़ेगी,
तो फ्रैगमेंट नहीं होने देता है, तो उससे आपको एलोकेशन आपकी एफिशिएंट हो जाती है, राइट. नाउ पैरेलल जीसी इज कॉल्ड थ्रूपुट कलेक्टर, राइट. सो व्हाटएवर if you have applications where you need more throughput, right, where your throughput is the primary need, and your application can take a little bit of latency here and there, right, throughput collector is best for you, right. It will make sure that on the longer run your application gives maximum throughput, right. And now this is called parallel GC.
Throughput in what parameters?
Throughput of your entire application, number of, let's assume, so whatever applications you have, right. I mean, let's assume I have an application which does logins, right. So my throughput is number of logins I'm doing over a period of time, right. So when you look at the entirety of your time, if you take enough longer duration, the number of the amount of throughput my application would have done this is fine tuned for that. It's fine tuned for throughput. लेकिन उसमें ये हो सकता है कि few of the logins might have taken longer time. Latency ज़्यादा हो सकती है, right. So you need to figure it out. Is your application fine for that? And I mean, I'm not talking about individual application where Revigo should have maximum of those applications, right. We shouldn't be falling into. So I'll talk about the CMS. That's where the CMS comes. So throughput collector, it maximizes your throughput, right. But then at the expense of latencies. There might be the cases where latencies might increase, right. And so throughput collector exactly work as we described in serial GC's algorithm वैसा ही है. It's just that it using the multiple threads to multiple threads spawn कर देगा, and those guys will do all the work, right. They'll divide the work among those threads, right. In all the new जो Java 8 में, so we call something a parallel old GC. I mean, again the term is very misnomer. There's nothing old with that. Actually, it's a good algorithm. But what it does is it does your old generation and new जो आपका young generation दोनों को parallel में करता है. मतलब it spawns multiple threads for that, right? तो आपका young and old minor GC and major GC both happens with multiple threads, right? वो उसमें रहता है throughput collector में, right? And this is by default in Java 8, right? Now coming back, so wherever we had a strict latency requirements, right? I mean, you have an application where you cannot afford for a longer pauses, right? That's where your CMS comes in, right? This is concurrent mark and sweep, right? So the way at a high level concurrent mark and sweep works is it does an initial mark, so that's where it pauses your application. but that pause is very small because what it does, I was talking to you about those root objects, right? जैसे आपका stack है whatever, it figured out कि वहाँ से what are the objects which are there in your old generation, right? That's the only thing it figured out, right? That time it pauses your application. After that, it does a concurrent marking. It uses multiple threads and start marking all the objects from the tree, right? This object, I know this is live. What are the object it is reaching out to? What are the object it is reaching to? He create that whole graph, right? पूरा वो graph बना देगा उसका. So that is done in a parallel way. Then again he pauses your application again for remark phase, because when he was doing the parallel marking, your application might have again updated the references, right? So he has to do that one more pause and do the delta part and figure it out if some updates have happened. And after that, it does a garbage collection. Now, it fragments the memory, right? Because the memory deallocation can happen from anywhere, right? So that's why it maintains the free memory as a free memory list. It's a simple linked list kind of data structure it maintains, where it knows that if I allocate from here, next where I can allocate to, and it keeps adding to the free list kind of thing, right? So that's also one of the, also CMS needs more memory, right? And that you can figure out why. Because when it is doing your GC, हाँ, और एक तो ये जो GC कर रहा है, it spends more time. Overall your application is being paused less, but end to end it's spending more time doing the GC, which means when it is doing the GC, objects are being allocated, so you should have sufficient space कि जब तक ये GC कर रहा है आपकी application चलती रहे, because it's parallelly doing that, it's not stopping your application. Through per collector, it stops your application, does it quickly and done with it. You might have a little bit pause, but then your memory requirements are less there, right? So that is why wherever you have a CMS, you should, or you need to have a little bit more bigger box, or bigger this one. So that is the expense you are paying for CMS, right? And that's where you're getting the latencies. You get very less latencies and all, right?
So can you explain, like in CMS, is it like creating a reverse bitmap or what?
For what?
Like you said that it creates another in first phase it creates a.
वो करता वही है जो वो वाला करता है, ठीक है? लेकिन parallel इसमें वो क्या करता है कि it tries to minimize the amount of time it has to stop your application, right? So to minimize that, what it does an initial mark. Initially figure out करता है कि you have a root, right? So wherever you have the root nodes, and I've told you those root nodes are mostly your, क्योंकि तुम्हारी Java की stacks, right? हर stack में जो object मिलते हैं, those are root objects, isn't it, right? वहाँ से वो देखता है कि कौन-कौन से old generation में मेरे पास objects हैं. So those becomes his initial mark. तब तक it has paused your application, right? After that it says that your application can now work. Then it starts as work in parallel. तो parallel क्या करता था पीछे से it keeps on figuring out कि इस node से कौन से objects reachable हैं, right? It keeps calculating all that, right? When it is done with that, now it knows that hey, this is my live objects and these are the garbage objects. But what could have happened during that time? References might have again changed, right? क्योंकि आपकी application run नहीं थी. He again does a final remark phase. उसमें थोड़ी देर के लिए फिर से application को pause करेगा, final remarking करेगा, and then it runs the GC again.
If I might add, in the remark phase इसीलिए चलता है, in the sense like it's more efficient कि उस टाइम पे और नया objects old में तो नहीं घुसा होगा, लेकिन पुराना जितना भी डोमिनेशन वाला ग्राफ था उसमें से कुछ और थोड़ा और हट गया होगा, बस थोड़ा और एफिशिएंटली करने के लिए थोड़ा एक और बार
वो लाइव ऑब्जेक्ट्स को स्कैन मारता हूँ,
वो उसका नहीं हर बार उसका कम होता जाता है स्पॉन, मतलब इट डजंट मीन दैट उसको रिमार्क फेज में इसको एग्जैक्टली सेम वर्क करना है.
रिमार्क फेज में अब उसने जो इनिशियली जो ट्री बनाया ना, अब खाली उसी ट्री को देखता, अब सारे को नहीं देखता है. उसी ट्री में अब एक्स्ट्रा और कौन गार्बेज कलेक्शन के लिए एलिजिबल है बस उतना ही देखता है, इसीलिए वो बहुत छोटा पॉज होता है.
और दोनों पॉज बहुत छोटे हैं तुम्हारे. और इसमें इनफैक्ट देयर इज अनदर, दिस इज कॉल्ड रीस्वीपिंग आल्सो. There is some parallel resweeping hidden. I'm skipping few things because then it will become very complicated. But the idea is same. एक parallel में वो resweeping भी करता है, तो even before he comes to the final marking, एक बार वो GC हटा भी चुका होता है, तो उससे उसको again he has to do a lesser work, right? And that also he does without stopping your application, right? So the idea is same, that he just figured out how to make sure to stop your application for a lesser point of time, because this guy cannot do that. Throughput collector जब आप चलाओगे, right? उसको कोई मतलब नहीं है जब तक उसका GC खत्म नहीं होता. Though he is running in parallel, he might be using 5 threads, 10 threads, but आपके application thread जो है उस टाइम पे काम नहीं कर सकते, right? He stops them, but then there is a clear advantage that he finishes your GC in very less time overall. Now again I'm talking about overall. There are two aspects here. How much time your application is being stopped? what time GC is taken. This guy will definitely take more time in GC क्योंकि ये stop करेगा, फिर parallelly कुछ करेगा, आपकी application भी चलती रहेगी, फिर कुछ करेगा, pauses कम देगा, overall he'll spend more time in reclaiming the memory for you. That is why you need more memory to survive that GC, right? This guy will not because it has stopped your application. You cannot allocate new objects. जितने थे जैसे ये exit होगा आपको ज़्यादा object देगा, मतलब it will give you free memory more, right? So you don't really need those requirements. That's why it's a little bit tricky to have CMS kind of thing, and we should only go for CMS wherever it is required, right? We have to be very cautious about it, right? And as I'm telling you, I mean, from my experience, whatever application I have seen in Revigo, I haven't seen a lot of latency-specific application, right? Application where few milliseconds matter for us, right? Utna time to we'll spending our SQS traversing our messages here and there, right?
So like I feel like the things like we have different boxes for schedulers and APIs, right? So at least for schedulers we can take that latency and we can like minimize the memory requirement.
Footprints, yes.
Yeah. So
यार मैं तो बोलता हूँ API में भी हो जाएगा वो, मतलब
हाँ मतलब API में तो हो ही जाएगा, scheduler में तो करना ही चाहिए.
Schedule में तो मतलब by default में हटा ही देना चाहिए अगर आप लोग तो this is Excel for all of you guys, right? All of you guys should come with your observation, right? And post your observation, keep divide कर लो अपने में मतलब compass में इतनी सारी machines है, right? Divide there and figure it out कि भी this is what my analysis is. And this is the start of story. We'll see a so JVM character, I'll just touch it, right? थोड़ा और complicated है इसका algorithm, right? अब G1 collector में what they have done is earlier we used to see जो हमने पहले वाली slide में देखा था, it was a very good demarcation कि भी ये तुम्हारा hidden space है, ये survivor 0 है, survivor 1 है, they are fixed, right? They don't change during the lifetime of your application, right? They remain fixed spaces. हाँ, you can when you initially start your application, you can tell कि भाई इसको ना तुम इतना ही space देना, that is in your hand, but after that there is no dynamic part there. G1 has changed all of that. What it has done is it has divided your memory into fixed side chunks, right? मेरे ख्याल से 500 I don't know it's a half MB के हैं कितने के हैं, but I forgot that part. But it divides your entire application into these chunks, right? And initially they are not marked anything, right? And as and when it starts allocating objects, it start marking them with the different spaces, right? So just say you start allocating memory, so this space will become hidden, right? Then in next cycle he'll say what is the unassigned. You are unassigned, by the way. You'll figure out what is the unassigned. उसको move कर देगा और उसको S mark कर देगा. So वैसे वैसे करता रहता है. And other thing which this algorithm depends on is that this guy doesn't really wait for your full GCs and all those things, right? In background it keeps figuring out that I think this space has the maximum of garbage, or maybe this partition has all the garbage, and he collects that, right? That is why it's called garbage first collection. He looks for the probability which part of these what are we talking about here might have maximum garbage, and he goes behind the maximum garbage, right? So this is how this is the default choice for the replacement of CMS, right? This is again will give you less pauses and all those things. Whatever CMS you have seen, it will do all those things. Plus, it has now divided your memory into dynamically allocated so that there is no fixed space for hidden. Those can shrink as and when you go. Those spaces will shrink. You might see at one point of time your hidden allocation is this much. It might shrink. आपका survivor बड़ा हो जाएगा, आपका gold बड़ा हो जाएगा. Whatever it is, it's a very dynamic in that nature, right? And this is also one step towards now again. Because this guy has these small boxes, right, divided, G1 collector is only efficient where you have a big box, right? आपकी memory ज़्यादा चाहिए. It will not run fine if you have a 2 GB heap space or 3 GB, maybe 4 GB, 5 GB. That's where this guy will start, showing you results and all, right? So smaller boxes के लिए, I'll still say go the Topo collector works well for us. Java 8 पे हम सब हैं. I haven't seen us using anything else. Again, this guy doesn't work very good with the Java 8, right? There is some problems with humongous objects. These guys have fixed them in Java 9, right? So don't try to use it with Java 8 unless there is a patch in Java 8 which has fixed. You can just search for the humongous objects problem with the G1 collector, right? Might have fixed in the later version of patches of Java 8. Initially it was not fixed. So what's up there? But going forward, as in how this G1 collector matures, this might become the default garbage collector if they fixes the problem with what to happen when you only have a 2 GB of heap, and if it works as efficiently as throughput collector, then it might just become a default one. This has, by the way, started coming as a default. If Java 11 application you start, don't give it any GC option, it will by default start with the G1. Right? But we'll look at the G1 a little, maybe in the next session sometime, right? And there are a few Zoom boxes I was looking at. Couldn't really go very deep into it, how they are, performing well over there. But maybe we can pick G1 also next time around, right?
सतीश, इसमें एक क्वेश्चन मिला था कि जैसे हम लोग कैंपस में देख रहे थे कि XMX का काफ़ी मतलब ऑलमोस्ट एग्जॉस्टिव मशीन है, वो इसलिए तो नहीं क्योंकि हम CMS यूज़ करते हैं, तो उसमें हम चाहते हैं डिफ़ॉल्ट हमारा हीप साइज ज़्यादा हो।
नहीं, CMS, so that is fine. अगर आप CMS भी यूज़ कर रहे हो, and even if you want your heap to be little bigger, that is fine. लेकिन CMS में होता क्या है कि see, if you have a box of let's say 4 GB, right? Now what we were talking about, when you give the heap space, right? Heap space is only here to here. This is not a heap space, right? तो आपने 3 GB इसको दे दिया और हाफ GB ये ले रहा है, हाँ, तो आपका 3.5 GB चला गया। उसके बाद क्या होगा कि Java allocates other things also. Stack बनता है आपका, thread stack बनेगा, Java को अपना चाहिए, तो वो 4 GB आपका almost use हो जाएगा, exactly. तो जब तक यहाँ उसका space is able to function well, the day all the spaces get filled, right? What will happen? He himself will have a trouble doing the GC for you, right? He will not be able to allocate जो GC चलाने के लिए उसको allocation चाहिए, तो उसमें क्या होता है कि your machine sometimes goes into a no data state, right? और उसमें क्या होता है कि machine stuck हो जाती है, GC भी नहीं होगा, आपकी application भी stuck हो जाएगी, then you have to finally kill the application. So the general recommendation is that you shouldn't have your XMX greater than 60% of the machine, right? उसको 40% आप खाली रखिए।
Irrespective of whatever GC allocated है,
doesn't really matter, exactly. So फर्क नहीं पड़ता क्योंकि ये space जो है वो GC के बाहर आता है, Java कुछ और चीज़ allocate करती है, thread stack वो सब बनाएगी, वो उसके बाहर आता है, and of course your operating system needs memory, right? I mean we are right. I mean it's not like your operating system will run some few things. Those are efficient, they don't need huge, but whatever, right?
तो जो ये सारे होते हैं जो स्टैक ग्रो करता है वो इसके बाहर करते हैं और इसके अंदर ही
स्टैक आपका बाहर आता है,
स्टैक अलग है और हीप अलग है ना,
इसीलिए मैं बोल रहा हूँ कि इसको अगर तुम 3 GB कर दोगे,
स्टैक तो ग्रो करने जगह नहीं
वही स्टैक नहीं है, फिक्स्ड है। जावा का थ्रेड जो होता है, व्हेन यू एलोकेट अ थ्रेड, स्टैक गेट्स एलोकेटेड विद दैट, और उसका होता तो फिक्स्ड ही है। जावा डजंट हैव अ डायनामिक स्टैक दिस थिंग एंड ऑल। लेकिन आपकी बात सही है कि अगर आपके जो नया थ्रेड है, राइट, वो एलोकेट हो रहा है, अब उसका स्टैक है वो एलोकेट नहीं हो पाएगा, राइट? सो बिकॉज वी हैव 4 GB तो हमने यही खत्म कर दिया ना, 3 GB इसको दे दिया, मेरे ख्याल से 256 MB से 300 MB ये लेगा आपका, राइट? थोड़ा बहुत कुछ ऑपरेटिंग सिस्टम वगैरह लेगा, तो यू हैव अ वेरी लेस स्पेस फॉर योर JVM टू इवन ब्रीथ, राइट? तो हो सकता है कि एप्लीकेशन स्टेडी स्टेट में सही चलती रहे, एक कुछ स्पाइक आएगी, then your application will get into a no response rate. And this I have seen in multiple applications. We have fixed it for Prime, at least 2-3 applications we have fixed it, right? And it was irony. How we fixed it, we reduced XMX, right? And the application got fixed, right? I mean,
actually like the best irony is like if you keep the key space small, your GC would be actually taking lesser time. Like the global pauses will be lesser because you will be doing short GCs very often.
So it is actually recommended. See,
especially for schedulers, it should be very small.
मतलब yeah, so general rule is that, so I'll show you few of the, so there is something called sawtooth, right? So when you see your applications, right, you can draw it here. So अगर आप अपने applications को देखोगे, किसी भी applications को, right, generally you should see for this trend. This is your time axis, right? This is how it happens. यहाँ आपकी memory allocate होगी, JC kick off होगा, memory allocate होगी, JC kick off होगा. If you see this pattern, you should be happy. This is called sawtooth, right? And this is very evident even for the minor GCs or major GC. It doesn't really matter, right? This is what you're talking about. If you have an application where full GC going right, don't be happy. It's a matter of concern, right? Because you have over allocated it. Right?
What I've seen is exactly sawtooth नहीं होता, थोड़ा ऐसे ज़्यादा, थोड़ा plateau होता है. फिर at least that's what I've tried in payment scheduler. थोड़ा ऐसे ज़्यादा, थोड़ा ऐसे जाता है. Scheduler का next cycle kick off होने से पहले ही like usually the schedulers are running in order of minutes, तो थोड़ा सा plateau होता है, फिर drop होता है, फिर sawtooth, फिर plateau drop ऐसे होता है.
So yes, I mean that's a good point that if we have any application where full GCs are not happening, it's a matter of concern, right? Matter of concern because we are spending very much, we're giving it memory unnecessarily. कुछ नहीं कर रहा उसके साथ. He's just sitting there. उसको GC, उसको मतलब काम करने का टाइम भी नहीं मिल रहा. He doesn't have to do anything. As I told you, the GC is lazy. अगर उसको जरूरत नहीं होगी तो कभी GC नहीं करेगा आपकी application का, right? And he's right in that way that if you're GC is not happening, everything is becoming slow over a period of time, right? Because then Java has allocated objects, it's lying there, it has to figure out all the stuff and all, your application will be slower, right? GC is happening, of course, at that point of time your application is stopped, but your application will be faster after that, right? So it's healthy to have GCs, it's healthy to have full GCs as well.
Satish, so ये CMS में after the first mark, तो अगर कोई नया थ्रेड स्पॉन होता है तो wouldn't it be garbage collected क्योंकि नेक्स्ट टाइम तो जो ट्री बनाया था उसी में देखेगा।
वो रिमार्क तो आपका जो नहीं इनिशियल जो आपका हुआ वो लाइव ऑब्जेक्ट्स कैलकुलेट करेगा और आपको उसको पता लगेगा कि ये लाइव ऑब्जेक्ट नहीं है, राइट? तो वो इनिशियल मार्क हुआ आपका। उसके बाद आपका दोबारा चलो उसका रिमार्क फेज भी आती है।
तो फिर से पूरा वो करेगा क्या स्कैन, मतलब
पूरा स्कैन नहीं करेगा, और रिमार्क में उसको पता है कि नई चीजें
ऑलरेडी स्कैन थ्रेड्स को नहीं करेगा, जो भी वो थोड़ा बुक कीपिंग करता है कि
उसमें भी कार्ड
वो स्टोर करके रखता है कि कौन से रूट ऑब्जेक्ट्स हैं जो मैं स्कैन कर चुका हूं,
तो उसमें फिर से कार्ड टेबल तो यूज करता है फिर से, राइट? तो वही करता है कि फिर से देखता है कि कौन से डर्टी एरियाज हैं जहां की नई एलोकेशन दोबारा से हुई है, और सिर्फ उन्हीं एरियाज को स्कैन करके ही ऑप्टिमाइज इन द रिमार्क फेज, राइट? उसका मतलब मेरे को एग्जैक्ट पूरा एल्गोरिथम नहीं पता, लेकिन जहां तक मुझे पता वहां कार्ड टेबल फिर से यूज होता है, राइट? कार्ड टेबल इज एल्गोरिथम व्हिच इज यूज्ड both in your making your minor GC faster as well as CMS type of area where you have to remark and all, right? तो वहाँ कार्ड टेबल मेरे ख्याल से दोबारा से यूज होता है।
तो पूरे टाइम के लिए वो उतनी मेमोरी लेके रखता है क्योंकि उसको पूरे हीप का सारा जो मैपिंग है वो रखना पड़ेगा अपने पास।
अब प्रॉब्लम ये है ना, क्योंकि अब उसका GC यहाँ चला लेकिन वो खत्म यहाँ हो रहा है।
हाँ।
अब पॉजेस उसमें दो थे, छोटे थे, लेकिन जब वो इतने से यहाँ तक चल रहा है उसने आपको एक भी मेमोरी वापस नहीं दी हुई है। आप पैरेलली चल भी रहे हो, अब ज्यादा मेमोरी एलोकेट भी करते जा रहे हो, यहाँ फ्री भी कुछ नहीं हो रहा है। तो उस ड्यूरेशन के लिए अगर आप देखा जाए तो आपकी एप्लीकेशन को ज्यादा मेमोरी चाहिए। It is why CMS are and they have another thing, right? Because bump the pointer वहाँ नहीं चलता है, they have to maintain those free list and all. That also needs a little bit more memory, right? To maintain कि मेरी free list क्या है or whatever bookkeeping and all it needs. So overall, your CMS becomes a little bit more memory hungry than the normal one. So guys, this is what it looks like, right? So there are a couple of commands I'll share with you guys where you can see what exactly is happening in your application, right? हम इसको live भी देख सकते हैं, but let's go through this log just to give an idea. I mean, I've randomly logged into a certain machine, right? Not intentionally checking what exactly is happening there. And this is exactly the application where I think G1 collector is running, but doesn't really matter, right? This will tell you this is your survivor 0 space, this is your survivor 1 space. If you look at this survivor space is 100, isn't it? लेकिन ये चेंज नहीं होगा, चेंज क्या हो रहा है आपका हिडन हो रहा है. So this command actually refreshes this every 5 seconds, right? So what I'm saying is give me the JStat Java statistics for the heap with the only GC. I'm only interested in GC. This command has multiple other parameters. We'll just focus. This is the one of the most important command in this area which I regularly use, right? ये आपका PAD है उसका, and then this is your 5 second पे उसको. यहाँ अगर देखोगे आपका हिडन स्पेस भर रहा है 34, 32, 36, 37. वैसे ये 100 जब होगा you'll see this becomes 0 and this becomes something else, right? And you'll see some value increasing there, right? And this YGC is your young garbage collection. YGCT is the young garbage collection time. Full GC, full garbage collection time, and total GC time, right? These are the kind of statistics you have. Look at this application, full GC is 0. This application has never done full GC, right? One of the reason could be that we have allocated more memory for this application. Doesn't really need it, right? Could be one of the observation, but because it's a short span of time, we don't know that. But this is right from starting. It's not from the time I have seen it. This garbage collection was 0 the moment this application started. So if application is running from 5 days, it has never done GC. So this is a global contest. These are not the live contest, right? अभी वाला नहीं है. ऐसा नहीं है कि अब से कितने हुए, right? Because you can see here ना, 83. आपके garbage collection तो हुए 83, young वाले. आपके बस major नहीं हो रहा उसमें. वैसे ही another, so this will help you if you go and if you see that your application is sluggish, right? Your first instinct should be to log into the box, look at कि यार GC में क्या हो रहा है. अगर वो यहाँ stuck हो गया है old में, right? I mean his old is pretty heavy, 25. But if your old is stuck somewhere between 80 and 90, right? And he's not able to reclaim, you see this counter continuously increasing but that not decreasing, which means that you might have a memory leak or you might have allocated enough memory कि वो reclaim नहीं कर पा रहा. That's why your application is either going to die soon or it's the verge of doing that. At that point of time, you should look at your GC logs. Right? If GC logs are enabled, and give you a comprehensive data. But here, so that is one thing which you should definitely look, right? If you see this thing is healthy, right, then it's fine. Otherwise, if you suspect something is wrong, is another command where you can figure it out histograms. It gives you histograms for your live objects, right? तो ये इस टाइम पे बता देगा कि तुम्हारी एप्लीकेशन की JVM में कितने ऑब्जेक्ट्स हैं, उनका काउंटर क्या है, राइट? तो मैंने रिव्यू को ग्रैब कर लिया था क्योंकि शुरू में यू सी द स्ट्रिंग्स एंड अरेज एंड ऑल आल्सो. सो आई जस्ट वांटेड टू फिगर आउट कि so this is by the way Zoom pace ticketing है ये application, right? The one we are looking at, right? So you look at this now. One catch. This guy trigger a GC. Now after this command, had I taken this ये full GC 1 बन जाता. And if I had seen my GC log, it would have seen that for the diagnostic command के लिए we have done the GC, right? Why? Because it only calculates the live objects. Now to calculate the live object, it has to do GC. उसको GC लेना पड़ेगा. उसको नहीं पता live objects क्या हैं. If you don't give live, तभी आपको garbage objects भी दिखा देगा. It will skew your metrics. You will not able to figure out कि हो क्या रहा है application. Like you might do a wrong analysis. So minus histo live will first trigger a GC. Once GC happens, it figure it out. So here if you say this is the guy, local date and attribute converter, and this has some 44 instances, I guess, 140 instances it has, right? This is the count and this is the amount of memory they are taking in byte, right? Not huge. I'll tell you why, because it doesn't calculate the amount of your composed objects. It's only calculated for that cell. So हो सकता है if this guy was holding references to 10 other objects, that count is not here, right? So that way, take it a little bit pinch of salt. This number will not give you much more information. If memory leaks are there, then much better tool, and maybe next time we'll do a live demo for this, something called JMAT, right? JMAT is by Eclipse, right? But for that, the same command, you just give it a binary and it dumps the whole heap. Again, be very careful. If you have allocated XMX of 4 GB, your heap size will be more or less 4 GB around, right? So you should have enough space to take that, and then you can load that in JMAT, and they will exactly tell you कि ये जो object है 626 count है, but how much memory is this guy taking, right? It will include all your outgoing references, incoming references, and all, right? But this is a very good first level tool, guys. If you have a memory leaks, you will see this counts increasing over a period of time. Right?
Actually, like if I might add, mostly like what I have seen in review applications is like memory leaks are mostly due to hibernates and all those things, like hibernate caches, not essentially leaks, like misused hibernates. And so like mostly like the gripping review or VM does not give any answer. Like you have to like sort by that count.
No, I mean I did it because I was more curious to look at what objects we are allocating.
Okay.
I mean I'm not saying I generally do that,
So,
but
yeah.
अगर मैंने इसको वैसे किया तो what will happen is top level जो objects
Yeah, top level like it will be strings
that will
and
not
arrays and
convey you much information, right? You can grab it by com or hibernate or
Yeah.
whatever it is. That's perfectly fine, right? So that's the idea, right? And once you have this, sometime even if you want to figure out the memory leaks, what you can do is that you can run this in a cron. I mean, we have done this for one of the VM application, right? We wanted to, so we had kept this in a cron and it used to run every 1 hour. And over a period of time, you'll figure it out if certain objects are increasing, right? Then you can figure it out that there is definitely some memory leaks happening around, right? Yes. But you guys are clear that in Java, memory leaks can happen, right? Right? You can create memory leaks, right? There's nothing hash map ले लो उसमें डाल दो memory leak होगी, right? I mean, don't release the reference. So yeah, caching is one of the most abused thing, or caching USs such as the memory leaks होती हैं. We cached objects, we forget to either clean them up or we don't do that, and that leads to memory leaks. तो इसका I can, if you have time, I can share a couple of things which I have analyzed very recently in the last 2 days, so that those are fresh in my mind as well, right? एक तो कल ही देख रहे थे शाम को high CPU in demand system. We can have a look at this. So you guys know how JStacks works. There's another very good tool which you guys should be very comfortable with. We call them. Where I think DevOps has even a job for that now, where you can take the
thread dumps.
Yeah, sorry. So thread dumps are nothing but the Java stacks, right? JStacks, right? So yeah, let me just log into one of the server and just show you something. किसी के पास वो है चार्जर वगैरह? Yeah, this is the same box I had logged in. So whenever you log in, so one of the problem you will see, क्योंकि we use this plastic beanstalks and all, right? So what happens is that so now these tools, what I'm talking about, they come with a JDK, not with JRE, right? JRE run time में कुछ नहीं आता, वो बस सिर्फ आपका Java run करने के लिए आता है सिर्फ, right? तो काफी सारे boxes पे हमारा JDK installed है नहीं वैसे. तो इधर यू कैन टेक हेल्प ऑफ द जो कि हमने जेनकिन की जॉब लिखी है. आई एज्यूम वो जॉब जाके वहाँ या तो इंस्टॉल कर लेते हैं या तो फिर वो मेरे ख्याल से S3 से कॉपी करके ले जाते हैं और उसको यूज़ करते हैं, राइट? तो दैट वी कैन डू. तो यहाँ पे तो मैंने मैनुअली इंस्टॉल कर लिया था, राइट? तो फर्स्ट कमांड वेरी हेल्पफुल इज द JPS कमांड, राइट? It's pretty much like your PS but only shows you Java processes, right? So first level gives you a little bit help. So this is your Java process which is running. Now let's look at it. What this process is, right? Now here you can see everything, right? I mean, we have given it 3 GB of MS and both minimum and max.
Could
This
you
is a good
increase
practice.
the font size?
Control plus, how can you do that?
Control shift enter.
It's all control plus
Command shift enter.
ठीक है. So you can, and this is a good practice. I'll share one document which I had written a long time back, which had these good practices. आपकी initial heap memory and max should always be same. There's no reason for them to be different, right? It's good your memory वहीं आपके application dump कर जाए, रात देंगे 5 दिन बाद जो है production में पड़ जाए, right? इसका कोई मतलब नहीं है. तो आपके पास उतनी memory है तो उसको दे दो. मतलब आप क्यों बोल रहे हो कि बाद में ले लेना, अभी मैं तुम इससे कम से start कर रहे हो, right?
ये probably पहले के टाइम पे ज़्यादा applicable होता होगा तो.
हाँ मतलब मुझे तो समझ में नहीं आया कि कब applicable था.
नहीं,
वोटिंग टाइम रिड्यूस करने के लिए
मतलब आप खाली उस पे नहीं वो allocate उतना ही करता है JVM नहीं. Only if you are like running multiple processes in the same physical machine. आप में same में 2 JVM चला रहे हो या कुछ कर रहे हो, वो फिर OS से request करके मांगता है ना कि इस ऑब्जेक्ट को थोड़ा और पेजेस allocate कर दो.
हाँ तो मतलब हमारे
लिए तो कुछ फर्क ही नहीं पड़ता है, बस लोग हीरो बनते हैं.
And that's where it says that I want to use the G1GC, right? So this guy is using the garbage first collection, by the way, right? And there you can actually tell it that hey, I don't want the pauses below 200 milliseconds, right? And that's the control you have over this CMS kind of collectors, right? You can tell it the max pause your application can kind of take, right? Verbose GC, and these are good things to do, right? You should always print your GC details and whatever it is, give it the log location and all, right? उसमें और भी रहता है GC में टाइम स्टैम्प प्रिंट करने के लिए, बिकॉज वो आपका टाइम स्टैम्प में करता है, आपको ह्यूमन रीडेबल में करना, उसके भी फ्लैग्स आते हैं. इट्स परफेक्टली फाइन. लॉग रोटेशन लगाया हुआ है, ऑल गुड थिंग, राइट? सब बोर्ड माइट बी यूजिंग समवेयर एंड दे हैव अ स्प्रिंग प्रोफाइल समवेयर, राइट? एंड whatever it is, not being relevant. Now what we will gonna do is we saw the JPS and now we're gonna see that what exactly is happening with the GC, right? So and these commands are very non-intrusive, right? They don't take much of your memory or whatever, so don't worry about that. I mean, you're running in production, yes, they are supposed to be running in production. There's no problem with that, right? Except the histo command.
Yeah, because it will do a GC.
It will do a GC. So अगर मतलब I got to be a little careful with that, right?
Most probably you are only doing it because it's already stuck.
हाँ.
ये थोड़ी ना अगर ये मुझे पता नहीं है तो पेमेंट से हर दिन ही करना पड़ता है, हर दिन बंद.
So this is exactly what you're talking. If you look at this pattern, right? वो जो 22 है वो 23 हो रहा है, right? And it will become 24 in some time. And if you give it some time, you start seeing कि वो S1 और S2 जो swap हो जाएगा, right? And old generation जो है आप देखोगे अभी तो it should be fixed. You should not increase now, right? 19, 20. लेकिन ये आपका क्या है? This is your G1 collector. That's why this fluctuation is happening, right? तो इसमें थोड़ा वो प्रेडिक्टिविटी कम रहती है, लेकिन तुम अगर उसमें देखते हैं हम ऐसी मशीन में जहाँ की वो नहीं चल रहा होता, फिर आई कैन टेक दैट इन कंट्रोल आल्सो. लेट अस ओपन S2 एप्लीकेशन. पुराना ही चल रहा है. Let's exit from this application. But anyway, that's fine. So we saw the command how it can tell you the what's happening there. We'll not run the JMap one because it'll trigger the GC. I'm sure कुछ होगा नहीं application में, but anyway, there's no point doing that, right? Now I'll come back to now JStack command is simple, guys, right? Just take a JStack, give the PID and give it the name of the file where you want to direct it, and it'll take the whole dump of it. JStack is very non-intrusive. Don't worry about it if you're taking a JStack from a live application. Just keep in mind whenever you take it, take at least 10 JStacks at the frequency of 5 seconds, right? One JStack will not give you any picture. Right? It's a very time snapshot में क्या हो रहा है, but उसके around क्या हो रहा है, you need at least 10 kind of these things for that. Right? Now let's look at the one problem which we were seeing yesterday, right? And how kind of your so this is the problem we were looking at high CPU, right? Now the high CPU, if it is happening, then your state of a thread has to be runnable, right? So state like this is the runnable one, right? So that is one thing which you can filter based on, and you can just look at the kind of threads which are in runnable states, right? And in this particular kind of application, right, where we were looking at it, you can see that it's doing nothing but it is reading the SQS messages. Right? And the whole time this application was on high CPU because the only thing which was doing was reading from SQS. Right? Now, if you go to that particular SQS, I hope I've still opened it. This might be the one because I was on live video yesterday. And I don't know how much of you attended last time. I had given one session on the SQS के ऊपर we use the long poles and all, right? So that was a very classic example. अब वो क्यों तो यहाँ से गायब हो गई, उसने डिमांड की थी वो
सबसे डिमांड है क्या?
हाँ डिमांड की है
सबसे ट्रैफिक का यहाँ था
JVM ने बहुत ओवर इंजीनियरिंग करा दिया.
So forget about that queue, but this is exactly same I'm talking about, you guys. Now look at what we are doing here. Number of messages sent to this is 0. Received is 0. How many empty messages we are reading? 75 messages we are reading, right? Every 5 minutes we are reading. Now the 75 in it is still fine. I've seen application reading 300 messaging in every 5 minutes, empty messages. That's where your CPU you are consuming, right? One, you are increasing the bill of AWS because they'll charge you for every empty read. That's fine, one thing. Another, you are spiking your CPUs. Because that application is not reading for one queue. I think that application is reading for at least 10 SQS. 10 एप्लीकेशन आप लगा लो उसको, अगर वो ऑन एन एवरेज 100 से भी रीड कर रही होगी, हर 5 मिनट में वो 1000 एम्प्टी मैसेज आपकी रीड करेगा, वहीं पे स्पिन करी जा रही है, राइट? और उसके साथ अगर कुछ मीनिंगफुल मैसेजेस आ रहे हैं वो फिर वो जो दैट इज अ बेटर थिंग, राइट? एट लीस्ट वी आर डूइंग समथिंग देयर. सो दिस इज हाउ यू कैन डू अ वेरी इनिशियल लेवल एनालिसिस विदाउट डूइंग मच, काइंड ऑफ स्पेंडिंग मच ऑफ योर टाइम, राइट? टेक सम JStacks and there is a good tool.
इसमें और भी रनेबल थ्रेड्स थे क्या?
इसमें सारे यही थे, बहुत सारे
इसमें एक था जो वन ऑफ द इशू जो आया था कि ग्राफाना की चेसिस सर्वर डाउन किया था, तो हमारा फेल ओवर हो गया बार बार. अच्छा. क्योंकि वहाँ पोलिंग वो एक सर्वर को रीच करने की कोशिश करता, डेटा पुश करने की कोशिश करता, डेटा एक सर्वर एग्जिस्ट नहीं करता था. तो वो शायद वो कंटिन्यूअसली चल रहा था.
कल इस वाले में तो नहीं मुझे देखा, इसमें 8 थ्रेड थे एक्टिव और 8 के 8 SQS पे लगे हुए.
एक में वो था कि CPU क्रेडिट खत्म हो गई थी और एक CPU 100 पे चल रहा था.
अब लेकिन वो तो स्क्रैप कर रहा है खुद ही,
वो नहीं, हम पोलिंग फ्रीक्वेंसी अपने में देते हैं और सर्वर का IP वगैरह हम अपने एप्लीकेशन. तो मोस्ट ऑफ वो पुश वो प्रॉमिथेस अलग है, ये पुराने वाला सिस्टम
ग्रेफाइट वाला.
हाँ,
ग्रेफाइट वाला है
उसमें
ग्रेफाइट वाला बंद कर दिया.
हाँ, वो पर हमने एप्लीकेशन से नहीं हटाना वो.
हाँ नहीं, इसमें ग्रेफाइट वाला मुझे दिख नहीं रहा था पुश वाला, तो हो सकता है वो दूसरा वाला हो और ये शायद वो वाला. तो इसमें आई डोंट नो, बट यू गाइस शुड somebody should pick up one task where जो फ्रेट साइड में भी have Athena library है, मेरे ख्याल से हम SQS वहीं से सब कुछ करते हैं.
हाँ, उसको चेंज करना है,
उसको लॉन्ग पुल कर दो, राइट? If somebody gets a time, if I mean I was planning to do that but not getting time, और मुझे Athena का थोड़ा इतना अच्छे से पता नहीं है क्योंकि Athena में जब भी चेंज होता है बहुत सिस्टम डिपेंडेंट है और मेरे ख्याल से कुछ तो आती है.
लॉन्ग पुलिंग में ड्यूरेशन क्या होता है?
लॉन्ग पुल में वी कैन सेट द ड्यूरेशन, तो हमें क्लाइंट लाइब्रेरी पे सेट करना है.
बाय डिफॉल्ट आई थिंक इट्स 20 सेकंड्स.
नहीं, वैसे वाले 0
है क्या?
इवन एन SQS, तो SQS पे एक पैरामीटर SQS पे होता है, एक पैरामीटर आपकी एप्लीकेशन में होता है. सो वेयरएवर यू, आई थिंक वी आर यूजिंग JMS, राइट?
नहीं, चेंज किया था ना
JMS ये Athena. तो फिर हमने तो वो यूज़ करना बंद ही कर दिया, हम डायरेक्टली AWS
तो AWS का SDK भी आप यूज करो तो आप सेट करना पड़ेगा।
AWS के SDK में ही हम तो लॉन्ग पोलिंग डायरेक्ट यूज करते हैं। अथीना में इतना गार्बेज है, उसको कोई चेंज भी करने नहीं देता आसानी से।
तो कैन यू गिव मी नो एग्जांपल वेयर यू आर रीडिंग
ठीक है, मैं पेमेंट्स का इंसेंटिव का कोड देख के बता
मेरे को आप एक क्यों एग्जांपल दें, देन वी कैन टेक दैट एज अ बेस एग्जांपल दैट हे गाइस हियर वी आर यूजिंग लॉन्ग पोल and we can see this here, right? And versus here we are not using, and this is what we are seeing, the comparison.
SNS क्लाइंट में अपडेट करा था आपने अथीना के अंदर
SQS का जो
SNS क्लाइंट
आपको लिसनर में करना है।
सॉरी SQS में
लिसनर में ये अपडेट नहीं करना, लिसनर तो JMX के ऊपर ही है। तो JMX में there is something called receive time out कुछ करके रहता है, right? वो आपको सेट करना होगा। And
नहीं, like should we even, if we are like altering that, why are we even using JMS? We should directly use the AWS SDK, right?
So JMS, see AWS guys have introduced JMS because
like people are lazy into like moving from that.
There are a lot of legacy application and
नए वाले application में वो use भी हुआ।
Before RabbitMQ you used to have JBoss application server जो कि पूरे JMS पे चलते थे, right? अब उस टाइम पे क्या था कि I have to migrate my application to SQS. It was a huge effort for me. So they introduced a bridge called JMS, which few people took as a
excuse.
Took as a कि this is a right design pattern, right? JMS was already sunsetting anyway, but yeah.
No, like what I am saying is, if it's already abstracted out in Athena, you should change the implementation in Athena and none of the client codes.
तो मैं वही बोल रहा हूँ ना।
implementation में change करना है किस तरीके से?
JMS मत use करो ना, वो direct AWS client कर लो।
हाँ वही करना है। तो duration क्या रखा हो?
तो give it 10
By
seconds.
default 20 होता है मेरे ख्याल, हमने शायद 20 रखा है। हाँ,
मतलब हर 20 सेकंड में एक बार पोल करेगा।
हाँ, poll
What will happen is it will poll. If it
जब
doesn't
तक
get a
नहीं मिलता है,
message,
तब तक
20
रुका
सेकंड का
रहेगा।
वही वेट कर लेगा वो।
हाँ।
तो तुम्हारी जो कॉल जो 20 सेकंड में 10 होनी थी वो कॉल प्रोड्यूस होके 1 हो जाएगी।
तो 20 सेकंड का डिले आ सकता है किसी इवेंट में।
हाँ,
डिले नहीं आएगा, मैसेज जैसे आएगा
आएगा वो दे देगा। 20 सेकंड बाद वो छोड़ देगा कनेक्शन।
अगर 20 सेकंड तक भी उसको मैसेज नहीं मिला तो वो वापस आ जाएगा फिर। तो उसमें थोड़ा मैसेज कभी डिले नहीं होंगे।
मैसेज डिले नहीं होगा, बट हम एम्प्टी पोल का 20 सेकंड का वेट कर रहे हैं।
और जब वो एम्प्टी होगा तो rather than coming back immediately, he'll wait for 20 seconds.
ऑन द क्यू कि आ रहा है कोई कि नहीं।
इससे तुम्हारी CPU कम हो जाएगी और तुम्हारे नंबर ऑफ रीड ऑन एम्प्टी मैसेजेस
अच्छा।
कम हो जाएंगे, दोनों कम हो जाएंगे उससे।
ठीक है, इट्स लाइक 20 सेकंड के लिए चैनल ओपन कर रहे हैं।
मतलब हाँ, it's blocking on that. If you look at it, it's a blocking call.
ठीक है।
It's blocking on, and when your thread blocks at your IO and all, at least your CPU doesn't go up, right? तो वैसे होगा। And because you're anyway using multi-threaded application, your other threads will keep running. It's not a big problem.
ठीक है।
तो यार एक तो ये हाँ
तो लॉन्ग पोलिंग पे वो थ्रेड्स ब्लॉक रहेंगे।
So this was one, and let me give you one more thing which I had analyzed a couple of days back. SSO में outage हुई थी. You guys might be aware that SSO was down for a few minutes. Right? This really might type down pause. This was very easy to see. What happened when the SSO outage happened first time, right? So that time we got to know that SSO outage hogi, and outage was already continuing for 10 minutes. So we didn't have a time, so we went and restarted the server and started working fine, right? So this time it happened again, which had to happen because we didn't fix anything, so it was bound to happen again. So जब वो हुई तो this time at least we took a opportunity to take the J stacks, right? And if you look at it, what we observed was all of the threads were stuck here. So this
Could you increase the font?
अब सही है।
हाँ।
बस यही थ्रेड देखो क्योंकि यही थ्रेड रिपीट हो रहा है आपका कम से कम 80 बार, या मेरे ख्याल से 179 टाइप्स। So what's happening is a very normal call जहाँ से we are doing some get access token, right? And for getting an access token, of course you have to figure it out कि कौन सा client है. You'll go to LDAP to read some data, right? Now if you look at it, it goes here and then there's something called generic key object pool. This is by Apache Commons, and it gets stuck at the borrow object. Take first, right? And if you look at this stack is repeated 70 to 80 number of times, right?
And waiting for a lock.
It's waiting for a lock. I mean, yeah, it's actually waiting for a lock here. So what exactly is happening is, and when I took the GC logs and everything was perfectly normal. Your old generation, कोई problem नहीं था, memory का कोई crunch नहीं था, CPU was not high, application was, your system metrics were perfectly fine, right? In fact, I have a dashboard for that. So here I could see everything, right? I mean, I could see, let's say, I have a basic statistics that number of open process file तो नहीं बढ़ी हैं, because I was looking at that कि are we leaking the connections and all, right? So there was nothing was happening here, right? Your CPU edges was very forward straight, load average नहीं बढ़ रहा था आपका. So even let's take this opportunity to see those sawtooth also, if we can see, right? तो अगर आप ये this is your GC one, right? So yeah, these are your sawtooths, right? You can see the sawtooths, right? Yeah. And इसको अगर आप बड़े वाले में देखोगे, if you look at it in a big enough window, this will become your sawtooths. तो अभी जा रहा है, इसकी collection आएगी तो भी नीचे आ जाएगा. It will go again and come back again. So this is what I was talking to you about, right? So this is SSO dashboard is as comprehensive GC वाली है. मेरे ख्याल से Compass में भी I think we have done it for, I guess, I don't remember, for Spring Boot की metrics export GC वाली. हाँ. तो वो आपको वहाँ पे भी मिल जाएगी सारी. So what I was saying is that here we didn't see an issue. The problem was that this we had introduced a thread pool. Thread pool was introduced because we didn't want it to. So earlier model was that whenever a call comes, you make a connection to LDAP, execute that, and close the connection. Now with that, what happens is you always incur a lot of time establishing TCP connections and all, right? So for that, we have implemented a thread pool so that you kind of. So what has happened was that this generic key object pool has a parameter called per key max number of connections in GPU, right? And that was fixed to 8, right? And that has to be changed to -1. Developer has changed it. It was pushed to stage. It was not pushed to production, right? So in production, this problem came because that it was limiting on thread pool. But it was so easy to debug once you took the JStack, right? We could figure it out that hey, he's going to thread pool, but he's not able to get the connection, right? He's stucking somewhere in that, right? And when you go and look at what is the value of that, you can see it over GMX itself, right? You open MB and look at the GMX. What is the max value? And this we could see from here itself, but it was not very evident. So I think I don't know, something was missing there because I had इसका मैंने इधर भी ग्राफ बनाया था. So here I was expecting that it would at least tell me waiting for connection वाला, but this matrix is somehow not working fine. इसने वहाँ पे भी वो zero ही दिखा रहा था, right? So this matrix should have increased. That number of waiting for the connections should have increased to 79 and 80. So that part I have to look at the code. Maybe it doesn't really work that way the way, or it might be a bug in the Apache code itself, right?
Waiting for connection is this for dependency on external calls, right?
नहीं, वो उसका LDAP pool जो उसने implement किया Apache ने, वहाँ के counter रहते हैं सारे. वो counters are implementing inside that. वो पूरे maintain रखता है कि मैंने कितने objects जो हैं वो pool में रखे हैं, उसमें idle कितने हैं, how many are actually working, and how many of guys are asking me, but I'm not giving them, right? So this was supposed to be that. But at least this is what I understood. Maybe I don't know, I understood it wrong or whatever. But I wanted this count to go up, and this should have been an alert for me that hey, there are a lot of guys waiting for a connection, they're not getting it, right? वो वाला somehow चल नहीं रहा था. So that is one instance where we could just take the JStacks and pretty much it became very evident it was easy for us to fix it, right? I mean, so I had taken 4 JStacks, but सब में यही, you can see that, right? This is filled with the same JStacks, right? See that? कुछ नहीं उसमें बस वही है. The whole application was stalled, right? And yeah. So these are the at least couple of instances which I can recall which happened recently. There were other issues also which we had fixed in SSO before. I don't know, maybe this dumps are for that. Try to open dump 1 and see, but this might be हमारा Redis पे कुछ एक call slow थी. I hope this is related to that. Yeah, you can see this. So when this issue, when we fixed, we took the JStacks and we could figure it out that there's something happening in the Redis. And what was that? That Redis was using star, right? We were using some finding out all the keys, right? And that's antipathic to be used in production in Redis anyway. So we could figure out those issues also looking at this, which we fixed. And जहाँ हमारी latency 400 millisecond आ रही थी, that reduced to I don't know under 20 millisecond or something, right? So throughput be. So this is when we were doing the performance analysis for SSO, and when we were looking at our LDAP and whatever it is, so there's a few fixes we made. But what I mean to say is that the base level, right, and whenever you have to optimize your application, right, you don't need any fancy tool, right, you don't need New Relic to tell you what exactly is happening. Of course, New Relic and all becomes very helpful when you really want to fine tune to those, final things and all, right. But most of the time, to fine tune a general Java application, there are enough tools which comes with the JVM, JDK. If you understand them correctly and we execute them, most of the issues you can just solve it in a right way, right. And for analyzing this thread dumps, there is, let us say, fast thread, it's a pretty decent. So this guy, where you can upload this JVM, your zip files, and then you can analyze it here itself, and it will tell you hotspots and all. मतलब अभी तो क्या है कि I have to move between runnable threads कहाँ हैं. This guy will divide them. It will tell you that hey, if your application is consuming more CPU, it may be because of these threads, right? Or if there is some memory leak, or there is some contention in the lock, or there is some deadlocks and all. Deadlock तो आपका JStack भी बताया था. It tells you the start there is a deadlock and all.
Link blocked queue पे पड़ा रहता है.
हाँ. लेकिन यहाँ पे you can analyze it in a much.
You can also upload multiple files below, so it gives a good compatibility report.
Correct.
At least we should try to take 5 thread dumps.
Right.
10 minutes. 10 minutes, no? 2 minutes.
Just take samples every 5 seconds. Take some 10.
Okay.
This thing that becomes very interesting. यहाँ पे
तो इस मैनुअली करना बड़ा
हाँ.
कॉन्सेप्ट ब्लॉक
मेरे ख्याल से जो वो वाली है ना DevOps वाली स्क्रिप्ट है, I think that वो एक ही लेती है, so I forgot. एक ही लेती है वो.
मेल पे भेजती है वो.
लेकिन वो एक ही लेती है शायद.
सारे वो ले लेते हैं environment के जितने भी servers होते हैं उनका एक ही.
उसको ना शायद हम थोड़ा modify करवाना चाहिए. So we should modify it in a way to give the number and the time duration. Because one is very misleading. At that point of time something might be happening, but it might be fixed in. जब आप 10 का सैंपल सेट लोगे and जैसे 50 सेकंड में तो समझ में आ ही जाता है कि क्या हो रहा है. So जैसे इसका देखते हैं एक बार. डेटा इसी का देख लेते हैं. इसको तो एनालाइज करने की जरूरत नहीं पड़ी थी क्योंकि वहीं सारे थ्रेड दिख गए थे.
कंपैरेटिव शायद सबसे ऊपर है.
यार वो मेरा वो ना वो है, वो उसका नहीं है, किसी और का.
इसका भी कंपैरेटिव मतलब अलग ही.
उसमें तो कुछ नहीं कर रहा हूँ. वेटिंग वाला हाँ लग रहा है ये कोई पुराना पड़ रहा है बस. बट एनीवे मतलब आप यहाँ आओगे तो अच्छे से मतलब कम से कम जब मैंने कल उसका लिया था ना डिमांड वाला, वहाँ पे कुछ CPU वाले क्लस्टर कर दिए थे इसने. 8 थ्रेड्स ने एक जगह क्लस्टर कर दिए थे. फिर मैंने जाके दोबारा देखा तो फिर रनेबल में दोबारा सर्च किया तो वही थ्रेड थे उसमें. तो वहाँ पता लग गया था कि CPU कौन थ्रेड ईट कर रहे होंगे, राइट. वो सब चीज़ें इस पर समझ में आ जाती हैं, राइट. Which is a decent tool for this.
So we have not covered heap dump का ज़्यादा. heap dump के लिए अपने वो यूज़ करता जो hidden और बस मेमोरी दिखा रहे हैं. थ्रेड डंप तो छोटा होता है तो हो जाता है. हीप डंप में फेस दिस इशू अगर 16 GB 32 GB की मेमोरी है तो वो बहुत बड़ा हीप डंप देता है.
So your heap dump will be proportional to amount of memory your Java application is taking as per now. So then be careful. अगर ले रहे हो तो उतना तुम्हारे पास डिस्पेस होना चाहिए. अगर कम भी है तो उसको S3 में जल्दी से कॉपी करके उसको वहाँ से क्लीन अप कर दो. Heap dump का what we'll do is that we maybe will have a next session and then we can go little bit detail. So what I wanted to cover was that little bit on JFR, but I'm trying to look at application where we can try it. So we need to find some Java application in production which will move to Java 11. And then we can use the free JFR itself. Because JFR gives you very comprehensive, and you can take a sample set also. You can take CPU के ले सकते हो आप, and then you can kind of analyze them and also. And it's very non-intrusive. What they say is that you can make it live in the production also, and then it takes pretty much like 2 to 3% of overload, like not overall 2 3, but on top of your JVM, so not take more than 2 to 3% of this. So maybe sometime next time we will analyze how to analyze your heap dumps to figure it out if there is memory leaks and all. We'll try to see how to optimize your JVMs, right? So one thing which we have seen is that you can go to your application server and see if your GCs are not happening, XMX is not equal to XMX, right? Those kind of things we can start looking at and start seeing if there is certain, if there is a room for optimization where we can reduce the machine size, right? Then we can definitely reach out to me, reach out to anyone in DevOps and they can help you with that, but that exercise we should definitely do that. Now open to questions. Anything related to this or anything else guys?
So जैसे CPU usage high means lot of runable threads. Similarly memory usage high means block threads बहुत सारे हैं.
तो मेमोरी यूटिलाइजेशन आपकी हाई तब होगी जब आपने बहुत सारे ऑब्जेक्ट्स एलोकेट करे हैं हीप के अंदर. तो वो जो मैंने JMap वाला दिखाया था, that guy should tell you that what are the objects we have allocated or not. Sometime we might have cached a lot of objects. उससे वो पता लग जाएगा कि हमने बहुत सारी एलोकेशंस तो
GC count भी बहुत ज़्यादा है.
क्योंकि GC काउंट एक्चुअल में होनी चाहिए राइट.
लॉग के अंदर एक्चुअली लॉग्स के अंदर आना स्टार्ट होता है कि थ्रेड एलोकेशन फेल्ड या टाइम्ड आउट.
थ्रेड एलोकेशन
मेमोरी के साथ
हमारे साथ जूम बिलिंग में ऐसा हुआ था कि बहुत सारे ब्लॉक थ्रेड्स दिखे थे. मेमोरी 99% टच कर गई थी बार तो थ्रेड डंप मैंने वही करा कि आधा घंटे के गैप पे 2-3 निकाल लिए थे. तो देखा कि सेम ब्लॉक थ्रेड्स हैं वो ब्लॉक पे वेट कर रहे हैं जो एक रनेबल है जो बेसिकली इक्वल वेट करके कुछ था काफका का. हाँ कंज्यूमर का थ्रेड ये हार्ट बीट टाइप का कुछ था और आई थिंक काफका ने अपडेट करा था मतलब कि उसको टाइम वेट टाइम करने का. मतलब हमारे में वो अनडिफाइंड हो रहा मतलब इंडेफिनेट वेट लगा हुआ था जिससे के चक्कर में मेमोरी खा के बैठा था. तो मतलब ऐसे कोई काइंड ऑफ ब्लॉक देखे हमने कि वो सेम ही ब्लॉक बैठे हुए हैं. तो मैं और वो चेक किया था
CPU यूटिलाइजेशन
पता नहीं उसमें मेमोरी 99% आई थी.
तो मेमोरी का क्या है कि अगर मेमोरी का आपको कोरिलेशन देखना है दैट यू हैव टू सी यूजिंग JMap ओनली. जिस टाइप से आपको मेमोरी नहीं दिखेगी बिकॉज़ जिस टाइप पे ओनली शो यू कि कितने थ्रेड्स हैं, व्हाट आर द थ्रेड्स के राइट. लेकिन उन थ्रेड्स पे क्या एलोकेटेड है वो आपको वहां से समझ में नहीं आएगा. सो JSTAGs मोस्टली हेल्प व्हेन यू नो दैट योर एप्लीकेशन शुड रिस्पॉन्ड, इट्स नॉट रिस्पॉन्डिंग राइट. मे बी इट हैज बिकम स्लो राइट. मे बी और हाँ वही सब आपको पता रहेगा उससे. CPU हाई क्यों है.
JMap में फिर वो ये बता रहे थे कि
वो आपका ट्रिगर करेगा आपका
GC ट्रिगर कर देगा.
लेकिन उसके अलावा कोई ऑप्शन
कोई
नहीं
तरीका नहीं है.
You can't inspect the live objects other than that, right? But in normal application that shouldn't be a problem. मतलब बस आप वही है कि we have to be see anyway your application is under stress or duress or something, it's not working, that's why you're debugging it, right? So at that time we should take JMap, look at the live objects and all.
जब जैसे रिसेंटली हमारा हुआ था तो हमारी एक बग की वजह से क्वेरी का साइज लगातार बढ़ता जा रहा था. तो हमारी हाइबरनेट की कैश ने सारी मेमोरी खा के बैठ गया था और एप्लीकेशन स्टक हो गई.
तो JMap किया था फिर उस पे.
तो JVM करा था करीब 4 GB का. तब पता चला था कि कहाँ पे चीजें.
उसमें क्या कैश किया था? फर्स्ट लेवल कैश किसकी बात कर रहे हैं? सेशन कैश,
क्वेरी प्लान कैश ही फर्स्ट है.
बेसिकली कैश क्वेरी को स्ट्रिंगिफाई करके कैश कर लेता है.
ये तो नहीं देखो
दो
हाइबरनेट में क्या है
एक लाइक लेवल 1 कैश है हाइबरनेट का,
वो लिमिट कर सकते हो.
सेशन कैश.
फिर लेवल 2 कैश है वो भी शायद कॉन्फ़िगरेबल है. लेकिन ये जो कह रहा है ना कि क्वेरी प्लान कैश, you can only configure the number of queries to be planned but you cannot configure how much memory it's going to take. और query plan cache के अंदर भी एक और चीज होता है कि all the named parameters within that query वो कितने objects रखेगा उसका शायद मैं मेमोरी दे सकता हूँ.
मतलब कुछ
तो हमने सब कुछ कम कर देता था
मैप ऑफ ऐसा कुछ था.
तो और वो बढ़ते ही रहता था और कोई कारण से वो गार्बेज कलेक्ट नहीं होता था. वो हाइबरनेट के पुराने वर्जन्स उसको कोई मैप में रखता था तो वो गार्बेज कलेक्ट मतलब उसका डोमिनेशन ग्राफ कभी खाली नहीं होता था, वो कलेक्टिंग नहीं होती.
I have also seen कि अगर we are not using query params जो SQL इंजेक्शन को prone होता है डायरेक्टली एक पैरम को स्टैटिक स्ट्रिंग में डाल देते तो वो अलग-अलग क्वेरी की तरह ट्रीट करता है.
इन क्वेरी के अंदर सबसे बड़ी प्रॉब्लम आती है क्वेरी के जितने पैरामीटर्स होंगे इनके अंदर उतने वो यूनिक क्वेरीज होंगे.
हाइब्रिड कैश के साथ in general have to be very careful. मतलब what I or whatever I have done in past is that whenever we use custom queries I used to bypass the whole hybrid itself. Then we used to write custom के लिए we used to write different DAO objects, native SQL करके. Hybrid itself gives you running native SQL also where you bypass the whole caches and all.
So नेटिव क्वेरी में भी मेरे ख्याल से क्वेरी कैश होगा, बस ये क्वेरी प्लान कैश नहीं होगा जो अनकंट्रोलेबल है.
हाँ वो exactly. So yeah, so इधर custom queries के लिए भी never used to use hibernate directly. और हम deletes और massive updates के लिए भी कभी hibernate use नहीं करते because I mean I don't know now hibernate I mean it's been a while I've used hibernate But the point we used to use hybrid, it never used to scale for massive updates, massive deletes, all those kind of things. It used to work fine for general workload and all. But then used to stuck when we used to have other requirements. But I mean, you're right. I mean, at that point of time, you guys might have seen in JMap, you could have pretty much figured out कि हो क्या रहा है, or you guys took the whole deep down.
No, we took the whole heap dump and analyzed it using the mat.
हाँ मतलब वो सही है अगर because that becomes a little bit far-fetched क्योंकि आपको लेना होता है 4 GB आएगा S3 पे जाएगा. So if you have certain requirement that hey, you want to instantly see कि हो क्या रहा है अभी पे, right? Then JMap is a little bit less intrusive और text file आती है उसकी तो उसका size बढ़ानी होता है. So that's how we think. But if you have a luxury to take heap dump and all, that will give you more analysis because mat जो है वो आपको inbound और outbound सब कुछ दिखाएगा. Right? You can see that who is reaching out to you and whom you are reaching out to.
नहीं आगे JMap से पता चल जाता है क्योंकि 80-90% एक ही चीज़ कर रही थी.
हाँ तो मैं तुम्हें नंबर वहीं लिख जाते हैं शायद उसका.
I think we should also set up a remote machine with this mat installed and we'll take remote heap dumps.
नहीं कोई तो अच्छा GUI वगैरह
हाँ GUI चाहिए ना
Eclipse
मतलब
का GUI
मैट यूज़ करे तो GUI
तो
चाहिए.
remote में अपन कर सकते हैं.
वो कर सकते हो वो एक्सपोर्ट वो नहीं एक्सपोर्ट
लिमिट हो जाता है मैट हैंग कर देता है अगर तुम 10 GB से ऊपर का ले रहे हो अपने इसमें चला रहे हो एक साथ इतनी मेमोरी लेगा एक टाइम के लिए तो डॉकर वगैरह चल रहा है तो लैपटॉप मशीन मतलब बहुत बार क्रैश होने को करना पड़ता है तो फिर वो वही heapdump.io जो है उस पे
मतलब 8 GB का मेरा हो गया था लैपटॉप
मतलब नॉर्मली
1 GB का एटलीस्ट बना था
बाकी सारी चीजें शायद आपको किल पड़ेगी 16 GB के तुम्हारे हैं
16 GB तो
तो should be able to analyze around
हाँ नहीं पूरा मेमोरी ज़्यादा लेता है रैम से सब हाँ
मेमोरी लेगा एक बार को तो
किसको पूरा ही
इंडेक्स
memory
का
का load करना
तो 1 GB के आसपास ले लेते हैं.
cool guys anything else
I think जैसा आप suggest कर रहे थे कि we can go back and probably check अपने जो
we should definitely do that that's only we'll do the second session
and उनके basis पे observations वगैरह would be maybe we can discuss in the next session.
right yeah so have your observations right I mean look at it play around with JVMs play around with your again abhi if you are not too much go to your stage instances first right I mean if you
एक लॉन्ग पुल और XMX का तो सेट कर ही देते
कंपास में हमने
हाँ,
GC लॉक्स ऑन नहीं करे
हाँ, और एक XMS वाला
बहुत जगह से बाय डिफॉल्ट के तो वो वाले आते हैं
हमको लगा वहाँ fix करना पड़ेगा वो
एथेनॉम में हाँ
we pick करो यार I can sit with them and we can peer review and we can do it आप pick करो तो कर लो फिर क्योंकि उससे बहुत फर्क पड़ने वाला है आई एम श्योर कि हम SQS में जो भी दे रहे हैं ना पैसे वो एम्प्टी मैसेज के दे रहे हैं क्योंकि हमारे मैसेज है ही नहीं इतने तो इनफैक्ट हमें SQS के फ्री प्लान में आ जाना चाहिए because SQS give you 1 million free messages
मैं इतना तो ट्रैफिक मतलब एक ही पैकेट का है वो जो DS वाले सारे यूजर्स का एक रेटिंग अपडेट करते हैं दैट टेक्स 80% ऑफ द पैकेट्स
नहीं वो भी पिगीबैक करके कर सकता है वो
वही जो वही ना जो 2 डेसिमल तक करा वही डेसिमल तक जो वेरिएशन सब भेज रिक्वायर्ड नहीं
ठीक है तो वो आप पिक कर लो वो फिर आप
लॉन्ग कॉलिंग